Swayam Prabha. Digital India. Educated India.
Welcome back, my dear friends. Very good morning, good afternoon, good evening to all of you. And this is the TQM1 lecture under the NPTEL MOOC series, and I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, we were discussing the different type of charts. The initially, like if I go back about 5-6 lectures back, so we have considered the X bar charts, art charts, which is the range. Then if range was not available, we wanted to go into the standard deviation. Then we considered the conformity, P, C charts, U charts, G charts, 8 charts. But the concept remains the same, that you need to basically have the central value, central line. The upper control and the lower control basically depend on what is the standard deviation. The standard deviation would basically be used depending on what is the overall coverage probability or the level of confidence which you have. So, if you want to basically cover 99%, you will use plus minus 3 sigma. If you basically want to cover 95, it will be plus minus 2 sigma, and so on and so forth. And also we considered that if the sample size was varying, we would basically divide by a changing value of ni's, n1, n2, n3. In case if it was not possible, we will use the average value, which is n bar, and do our calculations. So, continuing the same discussion. So, creating time between occurrences and the control charts. So, we did mention time and again, yes, consider the set of observations at 9 o'clock, 10 o'clock, 11 o'clock. So, say for example, 1 hour interval. So, that is 1 hour was just an arbitrarily example. So, suppose that defects or counts or events of interest occur according to a Poisson distribution, then the probability distribution of the time of arrival would be exponential. So, here I should basically mention something. So, generally consider this, there is a tailor machine in the bank or a machine in the shop floor, and jobs are coming at a certain interval and a certain rate, and they are being processed and then basically taken out of the system. Now, consider you as the person who is measuring the number of people who are coming per unit time. So, what that per unit time would basically depend on the type of example which you are doing. And another person who was also basically trying to find out that what was the rate of processing for each unit which was arriving. So, technically if the per unit time and if the time intervals between those per unit time was IIDs, which was independently and identically distributed, and if you are able to make that time interval as small as possible. So, technically the number of items which are coming between that time interval is discrete, which is Poisson process, and the time to taken to process each individual is a continuous distribution, it will basically be an exponential distribution. So, that is why the relationship of exponential and Poisson distribution is mentioned in this slide. So, again I will repeat it. Suppose that defects or counts or events of interest occur according to Poisson distribution, then the probability distribution of the time between events is the exponential distribution. The exponential distribution is highly skewed, and as a result the corresponding control charts would be very asymmetric. So, if y represents the original exponential random variable, then the appropriate transformation which we will try to utilize would be basically ratio of 1 by 3.6. But obviously, if the sample size increases very large, then obviously you can obviously with some obvious there would be error, but it would be quite nice that if you use the central limit theorem, have a certain mean, have a certain standard deviation. The sample standard deviation and the mean which you will be utilizing for the normal distribution would basically be coming from the actual population distribution from where you are picking up the observations and doing the work. Now, we will basically try to understand the choices, that when we will use the attribute charts and the concept, when we will use the variable charts and the concept of the variable control charts. So, attributes control charts have the advantages that several quality characteristics can be considered jointly and the unit classified as non-conforming if it fails to meet the specification on any one of the characteristics. So, if the several quality characteristics are treated as variables, then each one must be measured, and basically you should have to take corrective actions and pass the decisions accordingly, and either a separate and art charts must be mentioned on each of these variables, or a multivariate distribution chart should be drawn in order to understand the variations in a much depth. So, they are basically expensive and time consuming measurements, may sometimes be avoided by the attribute inspections themselves. Variable control charts in contrast provide much more useful informations about process performance. So, because the attributes are give you some quality, so good, bad, yellow, green, whatever it is, but the characteristics of the variables would basically give you some information based on which you can find out. It can be either the weight, the length, the height, or the numbers, whatever it is. So, quantifiable, which you can measure. So, continue reading along with me. Variables control charts in contrast provide much more useful information about the process performance than does an attributes control charts. Specific information about the process mean and variability is obtained directly. In addition, when points plot out of control on variable control charts, usually much more information is provided relative to the potential cause of that out of control signal. So, we are able to basically pass judgments for the variable control charts much more authentically and much more logically than for the attribute control charts. For a process capability study, variable control charts are almost always preferable to attributes of the control charts. So, except studies related to the non-conformities produced by the machines, the good, bad, or say color change is there, black or white, whatever it is, produced by the machines and operators, in which there are very limited number of source of information for the non-conformity charts and values. So, X bar and R charts are leading indicators of the trouble, whereas P or C or U are basically the tables which are basically used for the attributes. So, as it reads, they would not react unless the process has already been changed. So, they will basically continue to use the P, U and C charts for the attributes, and basically X bar and R charts, and also sigma charts for the variable charts. Choosing between X bar and R charts, a new process is coming on stream, or a new product is being manufactured by an existing process. So, in that case what you will do, the process has been in operation for some time, but is chronically in trouble or unable to hold the specific allowable tolerance. So, obviously you have to take some decisions accordingly, which means there is a huge amount of variability. If there is a variability, you will definitely should use the R or the range charts. The process is in trouble, the control charts can be used for diagnostic purposes or troubleshooting, and then you take corrective actions accordingly. So, destructive testing or other expensive testing procedures is required. So, obviously it will mean that the total cost is quite high. So, you have to be careful and basically do the testing, destructive testing for those products where you are sure you will get some information which is useful in order to pass some logical and very intelligent statement about the process capability of that whole process. So, it is desirable to reduce acceptable sampling or other downstream testing to a minimum when the process can be operated in control. So, continuing the discussion of choosing the chart type, whether the X bar or the R charts. So, attributes control charts have been used, but the process is either out of control or in control, but the yield is unacceptable based on that, whatever the information which you have. So, they are very tight specifications, overlapping assembly tolerances or other difficult manufacturing problems. So, the operator must decide whether or not to adjust the process, or when a setup must be evaluated, and then corrective action should be taken as necessary. A change in product specification is desired, and then you will basically want to implement those specifications for the production process as required. Process stability and capability must be continually demonstrated, such as regulated in industry, and you will basically take back the information from the industry and basically make your studies of of the charts, whether they are related to quality control or whether they are related to some variables being studied, whether they are related to some attributes being studied, obviously you will take corrective actions to find out where the problem is, but before that the charts have to be drawn. Coming back to the attribute charts, we mentioned that for the variable charts we use the x bar and the r, and sometimes the sigma charts, which is the basically standard deviations. Now, in the attribute charts you have the p charts, the c charts and the u charts. So, operators control the assignable causes and it is necessary to reduce process fallout. So, if there are any variations, the process is a complex assembly operations and product quality is measured in terms of the occurrence of the non-conformities, and so on and so forth. So, examples include computers, office automations, equipments, automobiles and the major subsystem of these products which are being basically considered. Process control is necessary, but measurement data cannot be obtained. So, in this case if they are not obtained, obviously you would basically have the attributes. Attributes will give you basically some information whether the process is as per the norm or outside. So, if you are not able to get exact data of the variables, you will try to utilize the attribute characteristics in order to study the overall process. Continuing with the attribute charts, so P, C and the U, and later on we saw that we had the G and the H charts also. So, historical summary of the process performance is necessary. So, attribute control charts as the P chart, C chart, U charts are very effective for summarizing information about the process for management review, and then the management basically can study and pass concrete judgment about the whole process, how it is going. Remember that attribute charts are generally inferior to charts for variables, which we did mention. So, always use the R or the S charts whenever possible. So, if you remember, the R was the range and S was the standard error. So, they would be utilized because they would give you some more extra set of information about the variability of the process is occurring, because say for example, the mean value is fixed, but if the variability is changing quite dramatically, obviously there is some problem in the overall process. So, that would basically be taken into consideration when you want to compare between where to use X bar charts and where to use R and sigma and the S chart. So, obviously, if you remember, I did mention fleetingly though that the R and the sigma or the S charts are the best way of trying to get the information, but obviously you will only do that in case if getting such information was not possible when you are trying to draw the charts using the attributes. So, now we will basically continue some discussion about the statistical techniques in further details. So, in statistical techniques can be useful throughout the product cycle, including development activities prior to the manufacturing process, in quantifying process variability, in analyzing this variability related to the product requirements and or specifications, and in assigning development and manufacturing, and in eliminating or greatly reducing the variability. So, this general activity is called the process capability analysis, and when the process had started, so it will be monitored. So, obviously, the information which is coming out, whether that the process is under control, out of control, we do not know. So, but obviously, the information is coming, we are trying to monitor it, or the team is trying to monitor it. So, the process capability refers to the uniformity of the process. So, there are two ways to think of the variability. So, obviously, in any process there would be variability, some would be external noise or which you cannot control, some would be internal one which you should definitely control. The natural and the inherent variability is a critical to quality characteristics at a specified time. So, that is instantaneous variability, and that can be utilized according to what the person who is doing the study can pass corrective judgment about whether to use the variable charts or the attribute charts and take corrective actions accordingly. The variability is a critical to quality characteristics. Over time, we define process capability analysis as a formal study to estimate the process capability. Major use of process capability analysis are predicting how well the process will hold all the tolerance, assisting product development designer in selecting or modifying a process, assisting in establishing an interval between sampling for process monitoring, that should also be considered. Then specifying the performance requirement for new equipment should be mentioned depending on new equipments are coming or not. So, we should also look At the other of the major uses of process capabilities would be selecting between competing suppliers and other aspects of the supply chain management, planning the sequence of product processes when there is an interactive effort of processes on tolerances, and you basically try to reduce the variability in the overall process. So, that is you will be basically tempted to use the process capability analysis. So, here is a diagram. So, figure 8.2 represents the histogram of the bursting strength of 100 glass containers. So, the glass containers are undergoing destructive testing, and you find out the bursting strength for 100 of them. So, a level of bursting strength is basically given along the x axis, and the frequency or the relative frequency or the probabilities are basically technically mentioned along the y axis. So, the table gives you the bursting strength numbers. So, you basically divide into intervals, find out how many intervals are there, and the finer you do, better would be basically going more towards the normal distribution. But obviously, it will depend on what is the whole set of data which you have. In this case, you basically 100 such set of informations are there. So, analysis of 100 observation gives you the bar central value, which is x bar is 264.06, S which is the standard deviation comes out to 32.02. Consequently, the process capability would be given and estimated at x bar plus minus the value of level of confidence which you want to place, multiplied by the standard error. So, it will be basically x bar plus minus 3 basically the overall coverage is 66 about 99 multiplied by 32.02, which by 32.02 is basically the standard error of the whole process. So, if I basically find out the intervals, so as I was mentioning, this is to 264.06 is the average value, plus minus 3 is 32.02, and you find out the PSI, which is the unit of the pressure, basically comes out to 264 plus minus 96 PSI. So, furthermore, the shape of the histogram implies the distribution of bursting strength is approximately normal. So, this is what I am saying, is that as you keep increasing the sample size, they would slowly tend to become the normal distribution. Thus, we can estimate the approximate 99.73 of the bottles manufactured by the process will burst between 168 and 360 PSI. So, note that we can estimate process capability independent of the specifications on a bursting strength. So, based on that, you try to find out that what is the level average value and what is the dispersion which is there below and above the mean value. So, in this second diagram which you see, the central line is given as mu and the dispersion on to the right is given by the US cell, which is the upper control. Then you have basically the lower control, and depending on how the process has been done, we can basically find out the UCL and the LCL. Now, one thing should be remembered, the sigma value which we have pertains to the standard deviation of the process. So, this I have been mentioning time and again, and the level of confidence will come from the so called value of Z. So, it is 3 or 2 or 1 would depend on the level of confidence. So, let me draw the standard normal. So, this is mu, technically this would be 0 for the Z distribution, and this value which we have is sigma. This technically would be 1 for the Z distribution, and if you move 3 such units onto the right and 3 such units onto the left, so that would basically cover about 99% of the overall coverage. I am repeating it, please do not mind, because the more you hear it, it will become much clear that how you can use the concept of the mean, the standard deviation to draw the limits considering the distribution is normal, using the concept of central limit theorem, based on the fact that the mean and the standard deviation of the normal distribution which you are using basically coming from the actual original population distribution. So, if it is Poisson, we will use the Poisson distributions mean and the variance. If it is a normal, we will use the mean and the variance on the normal distribution, and basically binomial one, you will use the binomial distributions mean and variance and use that in the central limit theorem. So, once we plot the observations for the bursting strength, so these basically comes out and if you remember the QQ plots which I mentioned, the 45 degrees line, they are not actually 45, there are some aberrations, obviously it is not a normal distribution. So, the values are given as 197 for the 20 observations, 200, 215 till the last one which is 301, 318 and 346. So, you want to basically interpret the results. So, the interpretation of the results would be mean of the normal distribution is the 50th percentile, which we will estimate from figure 8.4 as just mentioned. So, basically it will be 265 psi. So, pounds per square inch the pressure which is there. So, that would basically depend on what is the average value, and plus minus of that would give you the overall so called dispersion based on which you can say yes, within this range the bottles should not burst. And the standard deviation of the distribution is the slope of the straight line. Okay. Now, technically it means that when you are trying to basically have more observations or less and less observations, the values of the distribution would basically be either very shrunk or very large. So, this I am going to basically mention it very simply. Now, consider the distribution is normal, where I am drawing the x is normal with certain mean and certain variance sigma square. When you find out the best estimate of mu would be basically x bar n with a certain mean which is again mu, and sigma square by n is basically the variance, because that would basically depend that for each set of variance the variability between them will slowly start decreasing. So, if you take the value of n as large, the variance basically would now happen like this. I will try to draw it. So, say for example, for some n value it is this, if n basically increases it will become a more peaked one and it will basically be all packed up together. So, let me delete it. So, the second point says it is convenient to estimate the standard deviation as the difference between the 84th and the 50th percentile for the strand of the data shown, and the value comes out to be about 33 psi. Note they are not far from the sample average, and the standard deviation as we know is about 32.02. So, care should be exercised in using the probability plots if the data do not come out from the assumed distribution. Inferences about the process capability drawn from the plot may be seriously in an error, because the actual information based on which we are trying to draw the standard normal deviate or the distribution for the process control, there would be some conceptual error in what we are trying to consider. So, you want to find out the process capability ratios. So, the recall. So, now you want to find out that what is the overall coverage. So, if you see this formula, this would immediately make sense that what I have been repeating time and again. So, what we have from your side, if you are looking, the upper control limit is on my left hand side, the lower control limit on the right hand side on my right. So, the difference would basically be if you are gone plus 3 sigma onto the right and plus 3 sigma onto the left. So, obviously, the overall coverage would be 6 sigma. So, if you want to find out that what is the coverage, so obviously, it will be upper control limit minus the lower control limit divided by 6. 6 sigma, sigma basically being the standard deviation, that would give you the process capability ratios. So, this is what is happening. So, if I have the upper control limit, lower control limit, difference between that divided by 6 sigma would give me the ratios. So, in practical application, the process standard deviation sigma is almost always unknown. So, this is difficult to know and must be replaced by an estimator of sigma. In the other initial case, we found out that the best so called way of trying to find out the dispersion over the range. To estimate sigma, we typically use either the sample standard deviation S, or the concept based on which we are trying to get the standard error of the sample using the concept of the range. So, that was basically R bar divided by D2 would give you some concept of what the standard error of the sample was. So, continuing reading it, it means that when variable control charts are used in a capability studies, we will be tempted to use, or we will be required to use the value of R bar by D2, where D2 is constant which depends on the sample size. This results in an estimate of C, which is the ratio of CP, which is the capability ratio. And if we use the upper control limit and the lower control limit, so initially what we did, the ratio which was finding out was based on this fact of U I am trying to use as the upper control and L as the lower control. So, this was basically 6 sigma. Now, if we replace sigma by sigma hat, so obviously the C value would also be the estimate. So, hence it will be replaced by C hat. So, the process capability ratios have an useful practical implications, namely they give me the overall the value of P based on which I can do the calculations accordingly. Continuing the process capability ratios. So, these equations assume that the process has both upper and lower specification limits. For one-sided specifications, one-sided process capability ratios can be utilized. So, in this case it will be basically the upper control limit minus the mean value, or the mean value minus the lower control limit. So, obviously in that case it would not be divided by 6 sigma now, because 6 sigma was the overall coverages. So, it now will basically be divided by 3 sigma. If it is upper control minus mu divided by 3 sigma, we want to find out the process capability ratios or PCR, and in the other case if you are going on from your side, you are going to the left. So, it will basically mean minus the lower value divided by 3 sigma. Now, one should remember this 6 and 3 which you are using time and again would change basically to 4 and 2 depending on the overall level of confidence which we have for the problem, if we want to cover an area of 95%. In the case if we are basically certain that we will cover about 67% of the area, then in that case the process capability ratios, if the whole coverage was done, then the division would basically be 2 sigma. In the case, say for example, we are taking only one side, so it will basically be divided by, but the ratio would now become basically the numerator would be the upper control minus the mean value divided by sigma, and on the right hand side for my case, if you are looking from your side, this is the left hand side for the normal distribution, it will basically be the mean value minus the lower control limit divided by either 2 sigma or sigma depending on how you have basically framed the problem. So, you are basically, so this will be one sided process capability. So, you are required to find out the process capability for one sided for the container bursting example. So, suppose the lower specific limit of the bursting strength is given by 200 pound per square inch. So, you will use the x bar as 264, S as we already know is 32, and based on that when we find out the values of the process capability ratio for a level of one sided level of process capability ratios depending on the overall coverage as 6 sigma, then it gets divided by 3 sigma, and then sigma is replaced by sigma hat because this is not known, the value comes out to be 0.67. The fraction of the defective containing produced by this process is estimated by finding the area to the left of Z. So, this is what I am saying when we find out x, based on that x when we convert into Z, we always use this formula which is standard normal deviate. So, based on that we find out minus 2. So, under the standard normal distribution, the estimate fall is about 2.28 defective or about 22,800 non-conforming containers per million. So, based on that you can find out that in a 1 million or 10 million or 1000 or 10,000 or 1 lakh, that what would be the number of such defectives. So, note that if the normal distribution were an approximation model for the strength, then the last calculation would have to be performed using the appropriate probabilities distribution, and we will basically do the calculations accordingly. And let me mention one thing again, the mean and the standard deviation have to be calculated depending on what is the actual probability distribution for the population. Based on that, we again I am repeating, please forgive me for that, that it will basically be the central limit theorem coming into action, then you have to find out what is the level of confidence. Based on that, we replace them and do the calculations accordingly. With this, I will end the 32nd lecture and continue the rest 8, such that the overall coverage of the course would be done within the time frame of 40 lectures. Have a nice day. Thank you very much.